Hello, Psych 101 students. Welcome to Module 5, Chapter 8, where we will look at thinking and intelligence. So in this chapter, we will consider how we represent ideas in our minds and how we use these ideas to solve problems and make decisions. So it is Module 5, Chapter 8, Thinking and Intelligence. The big questions we will be looking at is, what is thinking? How do you use thinking? What is intelligence, and how is intelligence measured? So let's dive into learning objective 7 and look at what is thinking. And we'll begin with a definition. Thinking is any mental activity or processing of information, and this includes perceiving, learning, remembering, believing, communicating, and deciding. These processes are also known as cognition. We'll begin with the concept of schemas. These are mental structures or collections of ideas, prior knowledge, and experiences that help organize information and guide thought and behavior. We've certainly come across the term schemas before. So, for example, your experiences with music create memories that are organized into schemas. So, because of your schemas about country music concerts, you might expect to see guitars and people dancing. Because of your schemas about orchestra music concerts, you might expect to see a conductor leading the orchestra and people sitting still while listening. Schemas are related to your mental organization of both analogical and symbolic representations. An analogical representation represents the object within its features or characteristics. And what I mean by that is that when you look at the representation, you can see what you can see what it represents. So, like for instance, an image. I mean, both of these images on the screen here are analogical representations of country music and orchestra playing. I mean, you don't have to use any special techniques to figure out what they're showing. It's just it's the in the image. And similarly, when you look at a map, it's an analogical representation. You can see where the roads are and the cities are. Same with like a blueprint. You can of a building. You can see where all the walls are and the different rooms and whatnot. Whereas symbolic representation is a more abstract representation consisting of words or ideas. And so example is a word like the word violin. If you didn't know English and you see the word violin, you have no idea what it is. I mean, it's not the same thing as seeing a picture of a violin, for instance. Um, or think about the word lemon. There's nowhere in the word, in like as far as the construction of letters that would make you think of a lemon unless you've learned that word symbolizes the word lemon symbolizes an actual lemon. Same thing with something like a stop sign or a yield sign. Um, if you hadn't learned what it symbolizes, a stop sign, in no way makes you think to stop. If you didn't, once again, if you didn't understand any language, it might say stop. But if you didn't understand the language, or how would you know that to stop? It's only through learning. So the stop sign symbolizes the action that you should stop. Um, in order to be an analogical representation, it would have to actually show a picture of that represents stopping, and it doesn't. So some things are, we learn to associate through experience. These are symbolic representations that a certain image or shape, represents something. Other things are analogical representations, which you don't have to use language for. You can it's a picture or a blueprint, like I said, or a map, and you can see what it represents right in the representation. Okay. Categorization. When we use a schema to group things based on shared properties, we create a category. Let me just go on to the next screen here. For example, you might have two categories for instruments: country music instruments and orchestral music instruments. You also know that musical instruments within the categories differ based on their unique characteristics. So you can see the categories listed on the left here, and there would be certain members that fit into that category. There might be some, like a fiddle or violin, which are both the same thing. Just it's called a fiddle if it's in a country musical band, but it's called a violin if it's in an orchestra. Anyways, certain instruments would belong in one or the other, or possibly both, like the fiddle violin. Once again, you also, besides forming categories, you also have specific information about each of the items within the category, as shown here on the right. So concepts are mental representations used to categorize related objects, events, or ideas based on shared features, such as musical instruments, like we saw on the last screen, or fruits. You have a category for fruits and that are based on shared features. And it's a very efficient way to organize information in your mind. It means that you do not have to store every instance of an object or a relationship or a dimension individually. Instead, you store concepts based on the properties shared by certain items or by particular ideas. And this is a more efficient storage system. I have a category for fruit that I lump a bunch of different food items into, and I know that these food items all share certain properties. There are two leading models of ways that people form concepts: the prototype model and the exemplar model. According to the prototype model, the best example of a concept is used for categorizing objects you encounter. That is, the prototype is more representative of that category than are other items in the category. So for this reason, an orange seems to be the prototype of the fruit concept. It's like a very good example of what a fruit is. By contrast, olives do not seem to be very representative of the concept because they're not sweet, and therefore people tend not to categorize them as fruit, even though they are. So we form these categories, or or concepts, and it helps us decide what items belong in it and which ones don't. It will also lead to mistakes, as we see, as I mentioned, with olives, for instance, if they don't fit well. But there's always going to be some outlying members of a category that don't seem to fit well, and you have to kind of learn them as exceptions. Like a tomato or an olive being a fruit. So anyways, the prototype model. We compare to decide if something's a fruit, we compare it to our best example, which would, is perhaps an apple, orange. I mean, for some people, it might be an apple. It's the best example of what a fruit is. And you compare other things to that. In the exemplar model categorization, all concepts in a category are examples or what's known as exemplars, and together they form the category. So when you see something new, you compare it with all other similar things you've encountered and see which set of exemplars that it matches more closely. So suppose you had to decide what this animal is in this picture. Is it a dog, a sheep, or a pig? Well, the prototype model says that you will compare this to the best examples of a dog, a sheep, and a pig that you have stored in your mind. That is, you compare it to your prototypes of a dog, a sheep, and a pig. So in each case, you're comparing it to one thing in your mind that best fits these different categories. The exemplar model would say that you compare this to all of the examples, that is, the exemplars that you have stored of dogs and sheep and pigs. So I'm comparing this not just to one best example of a dog, I'm comparing it to poodles and to golden retrievers and to Rottweilers and every dog I've come across. And similarly, I compare it to every image of a sheep I have in my mind and every image of a pig. Um, and then I decide based on how closely it matches to the whole set of exemplars. So these are the two models, and it on first thought, a lot of people think, wow, the prototype model makes sense if because it would be much quicker. You're just comparing it to one thing. But remember, our minds work very, very quickly. And even in a split instance, you could do a comparison of this with every dog and every picture you've seen and every sheep, and so it's hard to tell just by um, looking into your own thoughts because of the speed that our minds work at. Even a quick decision, you may have already compared this to thousands of examples that you have stored in your mind, or hundreds of these. So anyways, these are the two models. Are we comparing it to one thing, the best example, or do we compare it to all the examples we know? Stereotypes are schemas, particular type of schemas, that allow for easy, fast processing of information about people, events, or groups based on their membership in particular groups. So stereotypes, first of all, they're not a bad thing. Um, they're natural. We all have stereotypes, and they're useful. Um, excuse me. We all have them. We all use them. Like, let me give you a quick example here. Suppose you're a caterer, and you have to make a decision about what to serve at a post orchestra party. So after this orchestra performs, the orchestra is going to be orchestra members. They're going to be at the party as well as people that were watching the orchestra. If you had to choose one or the other, are you going to serve wine or are you going to serve beer? If you had to choose, are you going to serve hamburgers and French fries, or are you going to serve fancy hors d'oeuvres? I mean, if you're trying to stay in business, you're probably going to use your stereotypes and choose to serve wine and fancy hors d'oeuvres. Because that would fit your stereotype of what these people would want. In another condition, maybe you're throwing a party for a baseball team after they win their championship. In that case, I'm probably going to choose to serve beer instead of wine. I'm probably going to serve hamburgers and fries instead of fancy hors d'oeuvres. And once again, I'm relying on my stereotype, but in many cases, these stereotypes are very useful. I mean, and this is why we form them, and this is why we use them. They So stereotypes, they affect our thoughts and our behaviors towards others, and they can lead us down the wrong path as well. They can sometimes be a negative thing. If you look at this photo here, this was a photo of the New York Philharmonic Orchestra back in 1960. The stereotype then was that women were worse musicians than men, and so this often led to the formation of orchestras composed of all men. Uh, Eventually, we changed our attitudes and we changed our audition procedures, and this has contributed to the diversification of talent in more modern contemporary orchestras. So at some point they started to use blind auditions, which meant that you couldn't see the people that had to decide, couldn't see who was auditioning. They would be placed behind a screen, or some kind of blockade, and you would have to just judge based on talent and how they sounded. And this is what led to women starting to be included in orchestras. Um, Stereotypes sometimes have unintended consequences, such as reinforcing sexist or racist beliefs about people in particular groups. So they can certainly have negative unintended consequences. And this is an example of a teenager that drew was asked to draw a picture of a scientist. You can see the one on the left here, the before picture, and like many children or teenagers, they would often tend to draw a man pictured as a scientist. But they have a special program at the Virginia Institute of Marine Science, which brings real life scientists into classrooms at in the area of middle schools and high schools, and so this was the picture before the student was exposed to the visiting scientist. But at the end of the semester, after months of interacting with a female marine researcher, the same student produced the drawing on the right. And this shows that if you encounter enough evidence or examples that go against a particular stereotype, you may engage in accommodation. Remember that from when we looked at Piaget's theory, the accommodation is the formation of a new stereotype or the changing of a stereotype. So you may engage in accommodation and change that particular schema that you have, as this student did. And that will conclude learning objective 7.